can even take a selfie with them, which is pretty cool. It's a really nice gimmick. And it's a really good use of deepfakes again. Well, one of the more obvious uses of it is in movies and shows. This was Star Wars The Mandalorian, where Luke Skywalker was deepfaked. And I showed this specific screen because Disney research actually created a good algorithm for deepfakes, which was very nice. And they did not seem to have used it for the first release of Mandalorian, and they used CGI instead, which was very janky. But later on, a YouTuber actually created a better version of it, as you see here. And I think they replaced the one on their Disney platform with the deepfake one later on. This is also an interesting example of Bruce Willis lending his face to a Russian telephone company advertising called Megaphone. So he just gave them the rights to use his face. So another actor played him, spoke Russian, and they created a whole advertisement of that. Just pretty cool. Campaigns are another place where these can be useful. So this was back in 2019, I think, in India, when there was a president or minister campaign where, because there's so many dialects in India, generally they don't really speak that many. So the campaign was aimed at like pushing out a campaign video in many different dialects of the person speaking those exact dialects without actually being able to. And a similar use case, this was a malaria campaign with Synthesia again and David Beckham, where they had him speak multiple languages and do a malaria campaign to raise money. And a very recent one, I just added this yesterday, I think. New York Mayor Adams used AI-generated robocalls to pass himself off to New Yorkers as multilingual. So people viewed it differently. Like, I find it pretty cool to have him do this because it's nice that he speaks, I guess, to different people in their own languages, but people would say like, this is fake, it's not real, he doesn't speak those languages. Like, there is a weird ethical boundary here. So what do we do now? There's good uses, there are bad uses. How do we deal with that? Deepfake detection. So deepfake detection has evolved over time. So back when the first deepfake came out in 2017, researchers have been scrambling, trying to figure out how to deal with them. And lots of detection mechanisms have come out over the years, and it's a pretty decently big field right now. So the most obvious way to do deepfake detection with at least AI is looking into pixel abnormality, which is something also our lab looks at, which is just feeding in raw images or like looking at compression, blur, noise, and analyzing them. There's coherence, which is more temporal. So it's looking at whatever I just said before, pixel abnormalities, etc., but temporally. So this first frame versus second and third frame, is there something weird happening? Like somebody mentioned the eyes are jittering around. That's more of a pixel level thing where, okay, because deepfakes are generated frame by frame, they might not be consistent over the video. Synchronization is another one. This is more of synchronization between different mediums. So you look at the audio signal, you look at the video signal, does the mouth move correctly at the time when it should, and etc. This could also not necessarily mean a deepfake, because sometimes audio signal gets shifted for whatever reason, but it's a method. Structural comparison is another one. This is where you just find out landmarks and the structure of the face or an object and match it to a reference of an original one, or anything that's supposed to resemble something that's true. Then there's biometric analysis, which is also more interesting. There's behavior analysis. So this is more identity-based. So you see a video of fake Tom Cruise. Does he behave like Tom Cruise? Does he have the same mannerisms? Does he like, I guess this is the easiest to show with Obama because he has such a distinct way of talking and a distinct way of using his hands when he's talking. So there's models that are trained more to identify people's personal behaviors. And then there's physiology, which is more about human biology. Does this person blink normally? The way they normal human should. Then there's more complex versions of this where like they analyze, because our ears move in accordance with our mouth when we say certain words, is that normal? And the signals like these, like there's even going as far as looking at blood flow. You can apparently find blood flow by just looking at a camera video of a person. So that's pretty cool. And which brings us to the DeFake project, the project that me and my lab work with. So the core of the DeFake project is providing explainable deepfake detection in the open world through a user-centric approach for journalists and intelligence analysts. So it started around in 2019 when deepfakes started to become a big problem, and we tried to figure out how do we tackle this problem, because we've seen a few deepfake detection models pop up. They weren't that great, and if we just start building something for regular people, it's going to be really hard. We started working with journalists. They're usually your first line of defense. They're the ones who scrutinize videos and try to figure out how to detect it. And we thought we'll help them first. So we did interviews with 12 journalists in large national and local news rooms, and we tried to find out what are their thoughts on deepfakes, how would they work with detection, and what kind of tools would they like to see. So this was a usability study, as I mentioned. And what we found that even in 2019, in general, the knowledge about deepfakes was low. It was better in large national news organizations, but local news organizations, they weren't really aware of what this technology was capable of. And even in large ones, there were people who brushed it off like, I won't fall for it, I'm a journalist. Like, it's my job to deal with these things. And yet, we'll see later, that might not have been the case. So we tried to find out what kind of interface they would need. So they needed a simple interface, they wanted explainability, and for some, they were probably not technologically possible. Like, they would say, like, can you tell me what the video this came from exactly? And usually that's not possible because models can learn from obscure content that might not even be on the internet. They want a lightweight detection tool that would be fast. That was hard to do. And pre-processing would have to be done in the cloud because they used to have these laptops with literally tons and tons of tabs open, and I don't know how those laptops survived. The metrics need to be simplistic. You can't just say use deep learning friendly metrics. We need to give them something more digestible, something they could talk about. So we chose fakeness, and this is sort of the interface that eventually came about from that usability study of, you'll see, like, there's different detection methods, there's the video, there's amount they processed, and just color-coded detections of what each different method has said. There's matching speaker's identity, which I mentioned is a identity-based detection of how much this person in the video matches what it selected person. Let's say if we select Elon Musk here, does this person act like Elon Musk and move around like them? Probably not. And like I said, we selected a fake. The value we called for detection is the fakeness value, which was somewhat controversial between people, but it usually, in more general terms, it was more digestible and people understood it kind of early on. We also worked on deep learning models and trying to figure out our own detection techniques. And we noticed that back when we started our project, there was no technique that looked at temporal information. And these are videos. All these deepfakes are created by frame. So we did a somewhat simple model where we tagged on normal image processing deep learning networks and attached a RNN, so recurrent neural network to it, which just in a nutshell would take blocks of frames and analyze them. And we did pretty well. This was a class and seg state-of-the-art model back then, and we beat it in most of types of deepfakes that were publicly available around that time. And we also did an audio spoof detection. So here we'll see our conval STM also did pretty decent. 2020, we upgrade that network with a better backbone model, ExceptionNet, which was kind of state-of-the-art around that time. And there's a more described network here, bidirectional STMs, followed by what we try to do is use scale divergence and what's the word I'm looking for? Cross entropy, right? And cross entropy, and try to see how just scale divergence would do and how cross entropy would do and how would they do in combination. And you can see a lot of 100% here, which were great as a research publication, but later on we would see that in the open world and random videos and with lots of compression, they don't really hold up as well. And there we go. And we still did better than most other networks we've tried, but the accuracy would fall off to 80s, 40s here. For some type of methods, it would still stick around, but that was unreliable. We can't give journalists assurance that we will do a good job. We upgraded even more, added more information. So now we will, in another model, we tested on another data set. Back then, Facebook started doing a competition, a deepfake detection competition. They released a small data set for deepfake detection. And we expanded our model to use optical flow. So optical flow is, you could see it as an extra form of information for visual information where you can compare two different frames and see where pixels have moved between the frames. And that provides the little vectors of direction alongside raw images. So we'll see, like, if we give it more information, how will we do? We actually did quite well. So with some form of networks, we got results, achieved results above 90%, and some with 99.5, which is quite good. We tried to see how compression, blurs, and noise affected, and there was still a pretty big fall off. Like, without any correction of the network, the fall off would, on average, would go to 45%, which is below guessing, which is bad. And here we trained, like, we added compressed images into the training process that bumped it up to higher percentages. But this shows that because we knew how much we compressed and what kind of data we're dealing with, we could make it better. But if we don't really know what kind of data is coming out and what kind of compression, what kind of encoding different platforms are using, and like Google will never really tell you what kind of compression system and what kind of codec they're using exactly. So now that's kind of a higher problem. We deployed a tool as well. And here's an example of how it works. So you put in a YouTube link, you have a video. This was a test video that I just did for this. So it pre-processes, and it's running with two different detection models here. So one detected it to be a fake, the second one, we're waiting for it, and fake. And overall fakeness is detected as fake. If you expand it, there's a large disparity of how much and where it detected to be fake. So it's not as accurate, but overall, in this case, it did a good job. So this tool is not open to everybody to access, and we just give it access to all our collaborators. It's built with Python Flask in the back end and React.js in the front end, and it's just run on our service at RIT. But it's often used by journalists from big organizations like NBC, CBS, and some local ones like the WRSC at Rochester. We also have a community drive of sorts to build a community of experts and researchers to be able to collaborate on finding deepfake videos. Like if there's some video that needs to be checked pretty quick, they could potentially post it on this social media platform, and maybe other researchers or other journalists or experts could comment on that. Like, oh, I've looked into this video, it's fake because this, or hey, I think this is a fake video, and somebody might actually refute it, that's real. This one is built on Mastodon-like technology, if you've heard it. It's federated social media that's distributed and all of that, and built on specifically Pleroma and a soapbox front end. So now we've talked about the negative effects of generation. Can anybody think about negative effects of actual detection? Yeah, go ahead. Exactly. So, and it can be. I'll give you an example. Imagine a journalist in Myanmar comes across a government video of a detained former treasurer. The treasurer admits to corruption and says that the former prime minister is also complicit. The journalist is mad. This isn't like them. She remembers that deepfakes exist and runs it through a tool that she saw online, deepfakinator.com. The website says that the tool is 99% effective. Great. She runs the video through, and the tool says that the video is 87% fake. That's it, as she expected. She has to publish this news right now, and she does. A Western forensics expert releases a report on a video that she published. Their analysis say that the video is actually real. This is not good. Now, she might have caused an uproar within the country, but forensics reporters do say in the video, and this was a real event in Myanmar, this has happened, because the tool said it's fake, and as you can see here, there's actually a different percentage, 98% fake, 93% fake, and 59% for another method. And people went crazy on social media, accusing the government and all of that. Witness did publish an article about it, but they said, even though this is not technically a deepfake, it could have always been a scripted video. They put a script in front of him, like, read this, or else. So this shows that an inaccurate detection tool might cause a lot of issues. These issues stem mostly because of biases. The journalist did not like the government. The journalist wanted the video to be fake. And once the tool just gave them one answer, they used it. So three important biases that play here. There's a cognitive bias that called automation bias, where people rely too heavily on the first piece of information they see. And first piece of information they see, and I think that's anchoring bias, my bad. This is anchoring bias, and I will talk about automation bias here. I flipped those by accident. So this is automation bias, where people favor suggestions from automated decision-making systems and ignore any contradictory information, mostly because of usually false marketing, because AI is so great, it is so powerful, it does all things for you, and a lot of the times people might be intimidated or just trust the system. And another one that's more, I guess, relevant to other fields as well is confirmation bias, where you have an opinion about this piece of content. Let's say an opinion about, more obvious one is Elon Musk. Elon Musk says questionable things on the internet. If he says anything else questionable on the internet, you'll probably believe it. That happened when his account was hacked by Bitcoin scammers, and so they posted a link on Twitter on his behalf saying that if you send money to this Bitcoin account, your money will be doubled. It's honestly something that Elon Musk can be crazy enough to actually do, but it wasn't. People got scammed. So it's hard to assess a bias when you just ask journalists because they might get offended. So we tried to do a study, a sort of adapted study from scenario-based roleplay called Dungeons and Deepfakes. In this study, we immersed journalists in a verification scenario in sort of a multiverse where they know the characters that are in the scenario, and they're asked to verify a video content that comes with a story. We let them take actions to verify. We preset some actions and we let them invent actions as well, because journalists usually have very different processes that aren't really the same across all of them. So this is where the Dungeons and Dragony thing happens, where we let them invent actions. We also introduce events, like after they've taken a few actions, we say, okay, this thing is happening in the real world right now. How do you react? Do you publish? The scenario ends once they publish. And what we like to observe is one of the actions we place there is the use of deepfake detection tools. And we observe how do they use it? How do their opinions change across actions? So they might start off thinking that this video is fake. Now, what we wouldn't like to see for them, like think this video is fake, it's a deepfake, I use the tool. Okay, the tool says it's fake, I publish it right away. Thankfully, most journalists didn't do that. So an example of a scenario would be here. Let's say you're an investigative journalist at a reputable news organization, and it's 2020, the elections are looming, and your editor links you a news article that was just published by a right-wing news organization. A video of Anthony Fauci claiming that COVID-19 vaccine is ready for mass production and distribution, but President Trump is holding it off to release it right before elections to boost popularity. That's absurd. But he also says your organization is going live with the broadcast in an hour, and you have half an hour to give them a script. So what do they do now? And then we just run them through the whole scenario of actions and see how they deal with that. We don't really tell them that this is going to be a study where we're looking at them and how they interact with deepfakes. We just tell them that, like, how would you verify it? So the outcomes of this study were slightly more positive, that less journalists were eager to just take the results of the tool, but the tool did confuse them a lot. So a lot of these journalists would publish just articles of their verification, what facts are real. Like if they called somebody up that they did not pick up, they say that. If they contacted a person or looked at social media and these are the discussions going on, that's what they say. If the tool gives them an answer and says it's fake, they don't necessarily publish it as fake, which is a good sign. But even the best journalists have fallen prey to over-reliance. Because in our study, we look at whether they over-rely on the tool, not just whether they're correct or not. Because for that case, it doesn't matter to us as much to figure out how they behave. So even if they are correct, let's say in that scenario, that specific scenario, we set it as this was a real event that occurred. The tool says it's fake. So they would lean to saying that it's fake. And if they said that it's real, regardless that it's the correct answer, they went against the tool. That's, I guess, a good thing. But we'll look at what other actions did they take. Did they take actions that seem to give them a correct-ish answer? So I talked about some of the results already. So tech-savvy journalists often do their due diligence to develop trust in the tool. A lot of journalists would say, I know this tool you gave me, but I will look at other tools that are out there and compare my answer. And maybe I won't just use the tool, I'll try to get used to using the tool, run a bunch of videos I have to see how accurate it actually is, how consistently it gives me answers. But some of the journalists in more local news organizations, they were more ready to believe it. So US-based journalists in particular did better on US-based scenarios. That's because more often than not in America, you kind of are able to find a somewhat trustworthy person around an event to verify it, which does not happen in a lot of other countries. So we try to put people in scenarios in countries where you might not believe the government or might not believe people involved. So that was also interesting. And we found out that if the video is a big center of the news piece, or the people in the scenarios are not trustworthy enough, they do try to put more stock in the tool and what it says, and they spend more time on the tool's results. And in the end, this was sort of a new methodology of a study, because most even scenario-based studies place people in more restrictive modes where they're not really allowed to create their own actions. We did, and they really appreciated and wanted it to be considered for like newsroom training in the future. So one of the things that came about, and when we started the study, it wasn't a big field, but now it's grown much more, is explainability. And that's a big thing that's required by journalists and analysts to be able to analyze content. You gave me a number, but this number doesn't mean much. Why did I get this number? So in computer vision research, there's various types of explanation. The major ones are heat maps. So GradCam explanation is usually trying to point towards the place of why the image was classified this way. So for this image, I'm guessing it detected some stand or something. And now it's for this specific class, this one's red. So if you look at the image, it's looking at these poles, and that's a camera stand or something. And then there's a prototype-based explanation, which gives similar images of characteristics for classification. So if it's a bird, it might look at a wing and say that because it has a wing, it's a bird. That's why we're classifying it as a bird. And things like these. For deepfakes, it gets a little more complicated, because you can get an answer from the tool, and the GradCam will point at eyes and mouth. You look at the eyes and mouth, and you might not see anything if it's a really good deepfake, because it's not really a wing that you can sort of properly see. And it might even say, point to the same places for real or fake. It's real because the eyes and mouth are normal, and it's fake because the eyes and mouth are normal. Like, okay, what does this tell me? Nothing. So this is why we're also I have a collaborator who's doing more of a study on trying to figure out useful information for journalists and intelligence analysts on what explainability do they want. So there was a paper back in 2021, which observed people's uses of AI explanations and how they respond to them. And there's an important quote from there. Explanations increase the chance that humans will accept AI's recommendation regardless of its correctness, which is very important. We're trying to help people understand and evaluate AI's response, but sometimes if you provide a justification for a response that's already wrong, people think that that justification actually helps them believe that it's right. So that's actually really bad. So this is why studying explainability in the correct context is very important. Right now, this is a study that's still going on. We're doing work with government intelligence analysts, where we interview analysts and try to find out because they are slightly different from journalists. Journalists like simplified information more often than not. Intelligence analysts appear to ask for more detailed information and give me as much information as you can. And we just early on, we found that they have a lot of workflow challenges because in image forensics, they have to deal with so many different tools. It's hard to keep track of what they're doing and collect information. They still do lack familiarity with deepfake analysis, but not as much. I feel like they have enough tools to spend enough time on a deepfake video to actually be able to verify it, but you can always make their jobs easier and faster. There's a need for standardization, which doesn't still exist in forensics. And as I said, domain-specific explanation. And they would like help with report generation. Who doesn't? You have to, writing reports is usually the tedious part. And these findings could translate to journalists. So to do that, we sort of expanded our old interface to be wider, to have more information and explainability, which I showed you explainability block in the explainability section. So we try to see how they perceive these things, and as expected, it didn't really go well because I don't really know what to do and here with this information. So pretty much done. This is the last slide. So deepfake field is a very big field right now, especially with the growth of AI, because AI is becoming pretty easy to access, and these tools are super intuitive right now. You have ChatGPT that lets you create all kinds of text, and although they're increasing the amount of guardrails, you used to be able to ask DALL-E to create a video of Trump doing things, but now you can't. And stuff like these. Regardless, it's a really big field. There's a lot of potential research in deep learning, human-computer interaction, or XCIs, AI explainability, a lot of cybersecurity problems, psychology, cognitive science, and of course, education, because I feel like because you can create any content of anyone doing anything, education systems kind of needs to change and incorporate media literacy, and so we know how to criticize content and understand it. And that's the big team that works on this project.